So this whole chapter is on matrices. And basically what a matrix is a matrix is what we call a rectangular array. All right? Or it's like a rectangular, a way to organize information in a rectangular form like this. And what it has is variables and constants, and they're arranged in rows and columns, hence the rectangular, right? And then they're enclosed in brackets. So you see an example of a matrix here. Each value in the matrix is called an element. All right, so the 8 is an element, the -2 is an element, the -3 is an element. Okay, together they form this matrix. So let's take a look at this matrix here. Let's take a look at the rows and the columns. So look at this one. This is one row. This is another row. And this is another row. So how many rows in total? This one has 3 rows. And each one of these is a column. Column 1, column 2, column 3, column 4, right? So 3 rows, 4 columns. When we talk about matrices, we always go with rows first, columns next. Rows first, columns next. And it'll take you a while to get used to that. But that's what we do. We just have to be consistent. Now, how do we talk about the size of a matrix? We don't call it the size, we call it the dimensions, right? So that's like the size, but we never use the word size. The dimensions of the matrix are given are the number of rows times columns, right? So it's m rows and n columns. And we write it like this, m by n. Okay? So for this one up here, the dimension is 3 rows, 4 columns, so we say 3 by 4. Not a 3 times 4, a 3 by 4 matrix. Okay? So let's take a look at this first one here. This is matrix A. What are the dimensions of matrix A? How many columns? How many rows? 2 rows and 3 columns, so this is a 2 by 3. Now, it says here to find the value of A23, okay? A23. This is like the 2 and the 3. It's not 23. It's 2 and 3. Those are the placeholders. So, for example, the 2, this means second row. The 3 means third column. So if I go to second row and third column, okay, that's -8, right? So A23 is -8. So then let's add another question here. What is the position or the name of element 5, right? So the 5 here, how would I refer to 5? It's A subscript what? 1, 2. Row 1, column 2. Okay. Now, why is it little a? Well, if the name of the matrix is capital A, then each of the entries inside is little a. So little a 1, 1, little a 1, 2, little a 1, 3, little a 2, 1, 2, 2, 2, 3. Okay? That's how we name them. All right. So there are some special matrices. The first is a row matrix. It's just a matrix with 1 row. That's all. All right? And it can have, as many elements in it as you like. So, for example, this one here, that's a row matrix. What are the dimensions of this one? 1 by 4. Okay? A column matrix just has one column. So what are the dimensions of this one? That's a 2 by 1, 2 rows, 1 column. All right, a square matrix has the same number of rows as it does columns. So this is a 2 by 2. And you can have a 3 by 3. You can have a 10 by 10. You can have a 54 by 54. It's just square. A zero matrix can have any size. It's just a matrix in which every element is 0. Okay? Just for fun, what are the dimensions of this one? 2 by 3. 2 rows, 3 columns. It'll take some practice. So that's a 2 by 3 zero matrix. Now, right, that's a 3 by 3. An identity matrix is a matrix in which every element, this should say main diagonal, every element on the main diagonal is 1. So take a look at this matrix. If you start at the very first element, and if you take that main diagonal going down, every element is a 1. Well, this definition is half complete. What do you notice about all the other ones? All the other elements in there? There's 0. So an identity matrix is a matrix in which every element on the main diagonal is 1, and the rest are 0. Okay? So can we write a 2 by 2 identity matrix? A 2 by 2 identity matrix has 2 rows and 2 columns. Let's talk about matrix operations. We're first just going to talk about adding and subtracting matrices. Matrices can be added and subtracted, here it is, if they have the same dimensions. This is super important. In order to add and subtract matrices, it has to be a 2 by 2 and a 2 by 2, a 3 by 4 and a 3 by 4. There is no other way to do it. Now, to add or subtract matrices with the same dimensions, you just add or subtract their corresponding elements. It's super straightforward. So basically, you take the entry here, 1, 1, with the corresponding entry here, 1, 1, and then it goes in the same spot, 1, 1. So A plus E. And then the next one over, you have a B here, corresponding place F, B plus F. Okay?
And then do you simplify that?
Right, you have a C plus a G and it goes here. Let's just do an example because, you know, we could stare at that all day long. But once you do one, you just have it. Right, so you're like a step ahead of me. So here we have A, B, and C. The first one asks to add A plus C. But look at A, it's a 2 by 2. And this is a 2 by 1. So it's not possible. Okay, now here I want to do B minus A. So you know what, let's just copy this down. This is B. Right? That's B minus A okay? All right, this is a 2 by 2, this is a 2 by 2. My answer is going to be a 2 by 2. So here's what I do. 10 minus 2, that's 8. It just goes there. That's all. Next one over. Minus 2, minus 5, minus 7. Next one down. Negative 3 minus negative 1. That's negative 2, right? Okay, it's negative 3 negative 3 minus, so negative 3 minus negative 1. And then the last one is 16 minus 3. That's just 13. All right, so there you have it. You just do corresponding points. Okay. Now, scalar multiplication. A scalar is just a constant, a number that is not in a matrix. It's just an outside random number. All right? You can multiply a matrix by a constant. In this case, each element is just multiplied by the value of the scalar. So here, if you want to find the product, you just multiply every single term here by negative 3, right? So negative 3 times 1, negative 3 times 0, negative 3 times negative 6 is positive 18, negative 3 times 5 is negative 15, times negative 2 is positive 6, and then negative 12. Are we okay so far? So far, pretty straightforward, yeah.
Yeah, as long as you keep it in the same order, right? You can multiply, like you could go this way, do the following first, and then...
Oh yeah, like you could do the 1 first, then the negative 2, then the negative 6, then the 4, then the 0, right? You could do them, you could just jump around the whole thing, it doesn't matter.
Okay.
Yeah. Same with the adding and subtracting. You could do, you could just be a rebel and just do like all sorts of like random pairings as long as you pair corresponding ones with each other. Right. Okay. So properties of matrix operations. So just like with numbers, whether you do A plus B or B plus A, it's the same. It's the same with matrices. Okay? Now, if you are dealing with numbers, and suppose I told you to do this, okay? One person might say, okay, 3 plus 5 is 8 plus 7. Another person might say, oh, I'll just add 3 plus 7 first. I get 10 plus 5. Either way, you get the same answer, right? Doesn't matter the order in which you add them. It's the same with matrices. You can add them in, like if you're adding 3 matrices, you could do 1 plus 3 plus 2, or you could do 1 plus 2 plus 3. The order doesn't matter. You could pick up a packet from here. It's the same with multiplying a scalar, right? You can distribute the scalar or add and then multiply. It's the same. So let's do an example. I have to do 3 times A minus B. So let me show you how to write this first. This is A. You should go in the order as is given. So this is A minus, now I'm going to do B. All right, and it's this whole thing times 3. All right, now there are a couple of things you could do. You could either multiply A by 3, 3, 3, 3, 3, 3, multiply B by 3, 3, 3, 3, 3, 3, subtract them, or you could do the stuff inside the parentheses first, then multiply by 3. That's what I'm going to do. So this is going to be 3 times, and let's just do A minus B, right? So it's going to be 5 minus 1, okay? Negative 2 minus 0. Okay, what about this next one? Negative 1 minus negative 2, how much?
3.
Negative 1 minus negative 2, write it out if you, it's plus 1. 0 minus 3, negative 3. 3 minus negative 1, 4. 2 minus 6, negative 4. And now I multiply everything by 3. So I'm going to get 12 minus 6, 3, negative 9, 12, negative 12. That's the answer. Okay. All right, now. Okay, how do we solve matrix equations? All right, you have been doing equations since, far back as like you can remember. So basically, we've given you things like this, and you have to solve for x, right? And so you do, okay, 3x equals 2, x equals 2 over 3. In this case, what does x stand for? X just stands for a number, right? X is just a number, and when I solve it, I get a number, 2 over 3. You could do the same thing with matrices, all right? So I could have an equation 3 times capital X minus 2, or actually A times capital X minus B equals, let's say, C, okay? And now when I solve for X, X is not a number, X is a matrix, okay? So those are called matrix equations. All right, how do we solve a matrix equation? We algebraically solve the equation for X, and then we substitute the given matrices. All right, so look at this one. We're given A, we're given B. We need to solve this for X. So first I write this, and now I'm going to solve for X. What do I do first to solve for X? Yeah, add A. So 2x equals A plus B, or B plus A, it doesn't matter. Now what do I do? Divide by 2. Now, when I divide by 2, is that the same as multiplying by 1 over 2? Yeah. So now X is 1/2 A plus B. And now I'm just going to do that operation like I did above. So X is 1/2 A plus B. We are going to add them first, actually. So X is 1/2 A. I like to write it over so I know what I'm doing, plus B. Okay, and here I'm going to give you a minute to do that, this entire thing. All right? Everybody, we're good with this one? Okay. So now this is 6.4. Now when it comes to chapter 6, we're going to be jumping around quite a bit here. Okay? So I'm going to do 6.4. I just want to stay consistent. I don't know why the book does it in a different order. All right, so here we go. Again, B minus A, right? I like to write my B minus the A so that we're not getting confused with everything. So go ahead and do that. Write down your B. First of all, do they have the same dimensions? Yes. Right. So write down your B minus your A. And I'll give you a few minutes to do this. Next one here, same sort of situation. Now you have 2A plus B. Right. What happened?
The last one? No, the one on top. It's 0 minus -1.
So it's positive.
Oh, sorry.
Yeah, it's positive.
Yeah. Oh, yeah, I got negative.
Okay.
0 minus.
This one here, look at what it tells you to do. It's 2 times A plus B. So who's getting multiplied by the 2?
A.
Just the A, right? So you're going to do that first. You're going to do 2 times A first, get the result, and add it to B. All right, so maybe I'll give you minus 12 and 4A. Right? And now, when we subtract these, what are we going to get? 3B minus 12 and negative 6 minus 4a. Now, what are the dimensions of that matrix?
Isn't that
A little a. What are the dimensions of that matrix? It's still a 2 by 1, right? Because this is still one term, so it's a 2 by 1.
Wait, isn't it 2?
Well, 3b minus 12, right? It's still a 2 by 1. So it's important for you to recognize that each one of those is one element. Okay? All right. So here is one example of how you might use matrices. How many of you guys take chemistry? Okay, so when you learned chemistry, did you learn about like NLMR, NLMS, right? The angular momentum of like the electrons and the spin of the electrons. Anyhow, okay.
Is this like the 1s2 stuff?
Almost. Okay, so let's talk about this one now. This table shows the highway and the city gas mileage of 5 different types of vehicles, right? So you have an SUV, a minivan, a sedan, a compact, and an APV. And then you have like the city mileage and the highway mileage. So for example, for the SUV, the city mileage is 23 and it gets 25 miles an hour on the highway. That makes sense, all right? So it says here now to organize this into a 2 by 5 matrix, right? A 2 by 5 matrix, I need 2 rows, 5 columns. Well, it's in a chart. It's not a matrix. So the matrix would just be 23, 21, 21, 42, 61, and here. All right, so that's a 2 by 5 matrix. So it's important to know, right, what these represent. Again, mentally, you know that like this is the SUV, this is the minivan, this is the sedan, this is the compact, and so on, right? And then this is city, and okay, so it says add the elements in each row and interpret the results. Do they present any relevant information? So if I were to add all of the elements in the row, what do I get? I just get like a cumulative, number of like MPGs. Does that represent anything significant? No, right? So no relevant information. But it's important for you to be able to know what that, because sometimes it might be something that's relevant. Okay? So for example, if these were, let's say, prices of an SUV, a minivan, a sedan, a compact, and or whatever that is, in like one country and another country, right? And if you were to add them up, what would that represent? Not the difference, if you were to add them up completely. If I were to add up like the prices, what would that represent? That would represent like how much the total cost would be if, let's say, you were to buy one of each. You know what I mean? Now, okay, why would you buy one of each? Maybe you're a company. Maybe you're a car rental company. I don't know. Okay? Right? Okay. And that's pretty much this. So, for homework, I would like you to do this. No, you're gonna do them on 2 separate sheets. Actually, the page P27, this is like page P. This is before page 1. Okay, at the very beginning of the book. I would like you to do this now in class, and then assignment 6.1, 6.4, you could do it at home. They have to be 2 separate assignments. Okay.